Hey everybody, this video lesson is the first of a number of video lessons that's going to take a deeper look into the structure of the electrons as they exist around the nucleus of an atom. Up until this point, our understanding of an atom is that the atom has a dense nucleus in the middle, and this dense nucleus is the source of all of the mass of the atom, with electrons floating around the outside, and there is a lot of empty space between the nucleus and the electrons. This is called the nuclear atom. This atom was developed in the early 1900s using lots of different experiments, multiple experiments in fact, that drew some conclusions about what the atom looked like. But there were some major deficiencies in this model of the atom. Principally, the deficiency that we are looking at is the fact that the electrons, if they behave like normal bodies floating around a central nucleus, then the electrons should collapse in on the nucleus, eventually destroying the entire atom. But we all know that atoms don't destroy themselves. They exist for many thousands of years before they disintegrate. Sometimes they turn into different elements due to radioactive decay. But for the most part, atoms are fairly stable. And so this observation that the atoms didn't destroy themselves was a key reason that scientists decided they needed to look a little bit more closely at the atom, and they needed to think about it in a completely different way. They couldn't explain how the atom worked, but they started thinking about it and running more experiments. The model that emerged after the nuclear model was something called the planetary model. Imagine the center of the atom is the nucleus, like the sun in a solar system, and the electrons float around the outside of the nucleus on definite paths like orbits, almost like planets going around the nucleus. And so each planet occupies a ring, and the planet can't leave its ring and travel to a different ring. It occupies the same ring and it just goes around and around and around and around. And in thinking about an atom in this way, we've solved the mystery as to why the electrons don't collapse in on themselves, because the planets don't collapse in on the sun. They just float around and around and are held in gravitational forces. The electrons likewise just travel around the nucleus, and they're held in place by forces that scientists couldn't quite explain, but they knew they had something that acted like it, the solar system. This model keeps everything that we know from the nuclear model, the dense nucleus, lots of empty space, but now we know that the electrons don't collapse on each other because they stay on their definite rings or their definite orbits. In addition, there was another convenient outcome of thinking about an atom and its electrons using the planetary model. Scientists were able to do experiments and show using mathematical calculations that the electrons can actually move between energy levels, and something very interesting happens when they move. They emit different colors of light. But I'll explain this in a little bit more detail on the next page. People have been observing for centuries that different elements, when put into a flame, emit different colored light. The red of lithium, or the orange of sodium, or even the purple of potassium can all be seen. So scientists were always wondering mysteriously what was causing the different colors. Now that they have the planetary model of the atom, they can connect the dots between the electrons and the different colors of light. Take a look at this picture of the planetary model, and you've got an electron at an energy level that is far from the nucleus. Scientists said that if you're able to heat up or electrify an electron, zap it, so to speak, it could jump to a high energy level. And when it comes back down to its original energy level, it will emit a specific color of light. And if you can get the electron to jump even higher and fall down, it'll emit a different color of light. And so they were able to prove this using calculations, and it was predictable. And because they were able to do that, it was discovered that electrons are the reason that different elements emit different colors of light. Now, there are hundreds of elements on the periodic table, and all of them have a different color light. Some of them are similar in red, maybe a different shade of red, but they're all slightly different. And you can identify, almost like a fingerprint, different elements and the different lights that they produce. So the planetary model had two things going for it. It could explain why the electrons didn't fall into the nucleus and destroy the atom, but it also helped explain the mysterious colors of light when elements are electrified or burned. But there was one major problem with the planetary model. The biggest problem is that the planetary model is two-dimensional. And if atoms were two-dimensional, meaning they were flat, then three-dimensional structures like you and I could not exist. So as a result, the planetary model is not the final model of what the atom looks like with the electrons floating around. But the next video lesson and the ones that come after it will help explain that a little bit more precisely for you. Well, that takes care of this video lesson. Thanks for watching.